Hello, this is the video number 1 for lesson 8.5. There will be 2 videos here, and you'll see why as we go along. Just a quick review of what we have done so far. In lesson 8.3, you learned how to multiply monomials together. So you had monomials times other monomials. Some examples of this is like when you had x to the 5th times, let's say, x to the 7th. You learned that we add the exponents and we get x to the 12th. Another example of what you encountered in lesson 8.3 is if I have 3x squared and I want to take that times 4x to the 7th. Those are both monomials, and you learned how to multiply those together. You learned that you multiply the coefficients, and that gives you 12. And then with the powers, the x squared and the x to the 7th, since they have the same base, you just add the exponents, so the final answer would be 12x to the 9th. So those are just a couple examples of what you did in lesson 8.3. In lesson 8.4, this should be pretty familiar to you because you just finished it up. You were multiplying a monomial times a polynomial, and that polynomial could have been just a binomial or a trinomial. It could have even been longer, but we didn't have ones that were too long. So an example of this is when we take 2x, which is a monomial, times a polynomial like 5x squared minus 6x plus 3. And so when you distribute that 2x to each item inside of the parentheses, that was lesson 8.4. So you would get 10x to the 3rd minus 12x squared plus 6x. So that is an example of lesson 8.4. In lesson 8.5, this lesson here, we are going to see 3 different types of problems. We're going to be multiplying polynomials together. So that could be a binomial times another binomial. It could be a binomial times a trinomial, or it could be a trinomial times another trinomial. So the problems will gradually get longer. In the first part, the rest of this first page of your notes, we are going to focus on the binomials times other binomials. The main method that we use to multiply binomials together is something called the FOIL method. And you may have heard of this method before. Well, the FOIL method has 4 letters, F-O-I-L, and they stand for 4 words that help us remember what to do when we are multiplying binomials times each other. The F stands for the word firsts. We multiply the first terms together. The O stands for the outsides. We multiply the outside terms together. The I is the insides. We multiply the inside terms together. And the L stands for the last terms. The lasts. Kind of awkward to put an S back there, but it's the last terms. So FOIL is the firsts, the outsides, insides, and lasts. And remember, as we're doing this, we're multiplying. So this first example here is just a real basic one. I didn't want to put any numbers in here. I just put the letters A, B, C, and D. So we have the binomial A plus B times the binomial C plus D. We're taking a binomial times another binomial. And I'm going to use the FOIL method to do this. So again, F is the firsts. And when you're looking at the example, the firsts are the first terms in the binomials. So it's the A and the C. So multiplying the A times the C, that gives you AC. I actually want to do this a little bit differently up here. I'm going to show it like this above. A times C. Okay? That's your firsts. I'm going to color code it here and change colors for the O. The O, remember, is your outsides. Okay, look up at the original problem. The outside terms are the A and the D. The outside terms, the ones on the, the very first term and the very last term. So those are the outsides. A times D gives me AD. And since everything's positive in this problem, I would put a plus sign. Because our final answer will be another polynomial. So far I have AC plus AD. Then I go to my insides. My insides are going to be the two terms that are on the inside of the problem. So you look at the original problem, the two letters in this case that are on the inside are the B and the C, and you're multiplying them. So what is B times C? Well, it's just BC. Again, it was positive, so I'm going to put a plus sign in front of it. So far my answer is AC plus AD plus BC, and finally I have my lasts. The lasts are the last terms in each binomial. So what's the last term of the first binomial? That's the B. We're going to take it times the last term of the second binomial, which is D. So B times D is just BD, and it also was positive, so I put a plus sign in front of it. So my final answer here is that long expression. It's kind of spaced out right now. I will rewrite it, but it's just AC plus AD plus BC plus BD. Now, because I used all letters here, we can't combine any like terms together. We will be able to do that as we get to the next set of examples where there's actually some numbers going on. But I just wanted you to get the hang of doing the FOIL method for this basic example. We multiplied the first, the outsides, the insides, and then the lasts together. Okay, now let's try some examples where there's actually some numbers going on. Again, we're going to use this FOIL method. So here we are with example number 1. We're going to start with the firsts. The firsts are x times x. X times x is x squared. Then we're going to do the outsides. That's x times 3. And that's just 3x. So you put plus 3x. The insides, that's 5 times x. So that's plus 5x. And lastly, we have the lasts. That's 5 times 3, and that's just 15, so we put plus 15. Then, as I mentioned before, you want to simplify this if you can, combine any like terms, and you certainly can. Right here in the middle, we have 3x plus 5x. We know we can combine that to give me 8x. So I'm going to start with my x squared, and then we have plus 8x, and then plus the 15. That's how you multiply binomials using the FOIL method. Example number 2 is very similar. It has a minus sign in it that we'll have to be careful with, but otherwise we're just, again, using the FOIL method. So we have our firsts, again, that's x squared, x times x. Outsides, that'll be x times positive 7, so positive 7x. Insides, this is a negative 2 times x, so that's a minus 2x. And my lasts, that gives me negative 2 times 7, which is negative 14. Combine like terms right here with our x's. So we get x squared, and then this is 7x minus 2x, that's 5x. Since that's positive 5x, I put plus 5x. But the 14 still has that minus sign in front of it because it was negative when we multiplied. So there's the answer. We just multiplied those two binomials together, and we get x squared plus 5x minus 14. In our third example, we not only have introduced some more minus signs here to watch out for, also we have numbers in front of our x's, coefficients there. So it just means that we just have to be careful when you multiply as you do each step. Let's do our firsts, like we did before. The first, 2x times 3x, gives me 6x squared. Outsides, that's going to be a negative 8x. Insides, that's a negative 9x. And my last, this is a negative 3 times a negative 4, which gives me a positive 12. Combining like terms here with my x's, this is a negative 8x minus 9x. Negative 8 minus 9 is negative 17x. And again, feel free to use your calculator with your positives and your negatives if you're unsure or just want to double check. And the x squared, the 6x squared and the 12 are just going to come down because there's nothing to combine them with. So your final answer will be 6x squared minus 17x plus 12. Okay, I encourage you at this point to pause the video, try numbers 4, 5, and 6 on your own, and then play the video again to check your work. I think that would be a good learning experience for you. Alright, hopefully you paused the video and you are ready to check your work. Here with number 4, it's going to be a special one. You'll see what happens. But we're still going to follow our FOIL method. So firsts gives me x squared. Outside gives me 4x. That one's positive. Insides are going to give me negative 4x because this 4 was negative. So minus 4x here. And my lasts, well, that's a negative 4 times a positive 4. That'll give me negative 16. This time when I combine like terms, the x's are going to completely disappear because this is a positive 4x minus 4x, and that's 0. They go away. So I am left with just x squared minus 16. You'll learn more about that in the second video where we'll work more with some special products that we get. Number 5, use FOIL. For your firsts, gives you, that's a negative 6x squared. Outsides gives me positive 12x. Insides give me, that's positive because it's a negative times another negative, so positive 2x. And my lasts will give me negative 4. Negative 1 times 4. Negative 4. Combine like terms just right there in the middle. That'll give me 14x. So my final answer is negative 6x squared plus 14x minus 4. And finally, with number 6, we had the introduction here of another variable, but we're still just going to follow our FOIL method. So let's start with our firsts. That's, 8x times 5x. That's 40x squared. There. Outsides, okay, that's 8x times negative 4y. So 8 times negative 4 is negative 32. And then I'm also multiplying with the x and the y, so you just write it as minus 32xy. Your insides here, this is positive 2y times 5x. 2 times 5 is 10, so positive 10. You also have an x and a y. So instead of writing it as yx, you just want to keep it in alphabetical order. So that'll be a plus 10xy. And then my lasts, We have 2y times a negative 4y, so that'll be negative 8y squared. And then you do have like terms right there in the middle with your xy's. So the first thing is 40x squared. Then you have a negative 32xy plus 10xy. That's going to be negative 22xy. And then finally at the end you have minus 8y squared. Don't try combining this first term with the last term. Even though they have the same exponent, they don't have the same variable, so you can't combine them together. So this right here is our answer. Okay, in the next part of the video, we are going to work with some of the longer problems with some trinomials. Before we start on the back of the notes, though, I want to point out that the FOIL method is really just a special way of doing the distributive property twice. You've known the distributive property for a long time now, so I just want to focus. Let's go back up here to problem number 1 and just watch as I do this. The distributive property is when you take something that's in front of parentheses times each item inside parentheses. So when I take this x and I take it times the other x, I'm distributing the x to the parentheses, the second set of parentheses. Notice that that's your firsts. That right there takes care of your firsts. Remember, your outsides is when you take the x times the 3. Well, that's just, again, distributing. You just distributed that x times the first x, or times the next x, and then also times the 3. That's your outsides. The insides then come from distributing the 5. So basically, you're just doing the distributive property twice. When you take the 5 times the x to do your insides, you're just distributing that. 5 times x, and then also 5 times 3, well, that's the same as the lasts. So the FOIL method is just a shortcut way of thinking about the distributive property and doing the distributive property twice. That'll be really important as we go to the back. So now let's go to the back of the notes. So as I just mentioned, the FOIL method is really just another way to think about distributing twice. That's what we're going to have to think about doing when we have binomials times trinomials. And then later on when we have trinomials times trinomials, we'll actually be triple distributing. So I wrote up here for the first one, for 7 and 8, what if we have binomials times trinomials? Well, we just double distribute. And you can't just say the FOIL method, because the FOIL method is really only working for binomials times other binomials. So if you try FOIL with this, you'll probably forget a term. So you want to think of it as double distribute. And that just means take each item in the first set of parentheses, or in the binomial, and take it times each thing inside the next set of parentheses. So you just have some distributing to do. So let's do that. Let's just go ahead and do example number 7. So if I'm just going to start with the 2x, one term at a time here, 2x times 3x squared, and that's 6x to the third. Then stay with your 2x until you're done distributing it. Take your 2x, now take it times the negative 4x. So that's negative 8x squared. Now take your 2x, you're not done with it yet. Take it times the positive 1. And that's just 2x. 2x times 1 is 2x. So plus 2x. Okay, now you have to distribute the other term that was in the first binomial here. Or in the binomial. This is a negative 5. So take negative 5. Take it times 3x squared. That's negative 15x squared. Then take the negative 5 times the negative 4x. That's positive 20x. Then, lastly, take the negative 5 times the 1. So that's negative 5. So these will of course be longer because we made our problem longer. Instead of a binomial times another binomial, we took a binomial times a trinomial, something that had 2 terms times something that had 3 terms. You still need to finish it by combining any like terms that you can. So just start with your highest exponent, which is the 6x to the third. Are there any other x to the thirds? No. So I'll just rewrite 6x to the third. Can't combine it with anything. There are a couple x squareds to put together. This is a negative 8x squared and then minus 15x squared. That is a negative 23x squared. Those are done. And, you know, I think I did this in a previous lesson. I might cross them out so that I don't look at them again and they don't confuse me. Then you have some x's you can put together. This is a positive 2x plus 20x. So that's plus 22x. Those are done. And finally you have a minus 5, and there's no other numbers to put it with. So that's just a minus 5 at the end. So there is our final answer. Why don't you try pausing the video, try number 8, and then come back and check it. With number 8, we're going to double distribute again. So here I am going with the a here. I'm going to start with this first term, take it times each item in the second parentheses. So a times a squared is a to the third. A times negative 8a is negative 8a squared. A times 5 is 5a plus 5a. Then I'm going to distribute with the minus 3. It's a negative 3, so negative 3 times a squared is negative 3a squared. Negative 3 times negative 8a is positive 24a. Yeah. And then negative 3 times positive 5 is negative 15. Then I need to look at that and combine any like terms. There's only one term that has an exponent of 3, so that's just going to get rewritten, a to the third. Put my squareds together. That's negative 8a squared minus 3a squared. That would be negative 11a squared. Put my a's together. They're both positive. That's nice. So 5a plus 24a is positive 29a. And finally, I have the minus 15. So there's my final answer for that one. Okay, and then finally, our problems are going to get just one more step longer. We're going to take a trinomial times another trinomial. So that's 3 terms times 3 other terms. And as you can imagine, with this is going to be like triple distributing. We're going to take each item in the first trinomial times each item in the second trinomial. So we're going to have lots of little arcs going on here. Okay, let's just get started with number 9. Again, I just start with the very first term, 4a squared, and I take it times each item in the second polynomial. So 4a squared times 2a squared is 8a to the fourth. And then 4a squared times a minus a is minus 4a to the third. And 4a squared times positive 8 is 32. So positive 32a squared. So we distributed the 4a squared. Now we need to distribute the 3a. It's a positive 3a. So take that positive 3a times each item in the second parentheses. So 3a times 2a squared is positive 6a to the third. 3a times a minus a is going to be a minus 3a squared. 3a times 8 is 24a, positive 24a. And finally, we are going to take this minus 7 here. Don't want to forget about that. And you also have to distribute it. So we're going to take it times each item in the second parentheses. So we have a minus 7, a negative 7 times 2a squared. So that would be negative 14a squared. And the negative 7 times negative a is positive 7a. And then negative 7 times positive 8 is, wow, negative 56. Okay, so we have this really long polynomial here. You need to combine like terms. So, any a to the fourths? Just the first one. So 8a to the fourth. What about my a to the third? So I have these two right there. That's negative 4a to the third plus 6a to the third. That's positive 2a to the third. Those are done. Cross those out. All right, a squareds. I have 3 of those. This is 32a squared minus 3a squared. So that's 29a squared. 29a squared minus 14a squared is 15a squared. So plus 15a squared. Cross out all those. They're done. Now I'm down to my just plain old a's. This is a 24a plus 7a. That's 31a. So plus 31a. Those are gone. And finally, the minus 56. There's nothing to put with it, so just minus 56. So there you have a polynomial that has 5 terms in it for our answer. All right, number 10. Kind of ran out of room here. Let's see if I can draw a little line. Okay. Here we go, triple distribute again. So, start with my first term in my first polynomial. Take it times each item in the second polynomial. So you have y squared times y squared. That's y to the fourth. Y squared times minus 6y is minus 6y to the third. Y squared times positive 5 is plus 5y squared. Now we move on to the next term, which is 7y. We're going to distribute. So 7y times y squared would be positive 7y to the third. 7y times negative 6y is negative 42y squared. 7y times positive 5, that would be 35y, so plus 35y. And then we have our negative 1. We're going to distribute that times each item in the second parentheses. So negative 1 times y squared would be negative 1y squared. Negative 1 times negative 6y would be a positive 6y. Negative 1 times positive 5 is minus 5, negative 5. Almost ran out of room there. And then you combine your like terms. So start with your highest exponent, y to the fourth. There's only one of those, so just rewrite it, y to the fourth. Combine any y to the thirds. It's those two. That's a negative 6y to the third plus 7y to the third. That's going to be a positive 1y to the third. So I'm going to put plus y to the third. You can put a 1 in front of the y if you want. You don't have to. You can put it there or not. Those are done. Now I look at all my squareds. 5y squared minus 42y squared, that's negative 37y squared. And then minus one more would be negative 38y squared. Those are all done. Plain old y's, I got 35y plus 6y, that's 41y plus 41y. And the minus 5 at the end, there's nothing to combine it with. So there is your polynomial answer. Alright, the final thing to do for our notes is a couple of application problems. This lesson can definitely apply to area and volume, so that's where we're going to see it the most. In number 11 here, we have the dimensions of a basketball court are represented by a width of 2y plus 10 feet and a length of 5y minus 6 feet. Write an expression for the area of the court. Well, basketball court is one big rectangle, so area equals length times width. And so we just have to take the length times the width, or the width times the length. You can write them in any order. So I could easily just put 2y plus 10, that's a binomial, times the other binomial 5y plus 6. Or no, 5y minus 6. Since these are both just binomials, we're going to use that FOIL method, which again is the same as just distributing twice. So let's go with our firsts here. 2y times 5y is 10y squared. Outsides gives me negative 12y. Insides gives me 50, positive 50y. And my lasts gives me negative 60. Combine like terms right there with those y's in the middle, so that's 10y squared. Negative 12y plus 50y will be positive 38y. Then minus 60. That's an expression for the area, but since it is area, you want to make sure you label, and that would just be, oh no, not units, because they told us it was feet. So feet squared. Up here in the problem, they said the width was 2y plus 10 feet, and 5y minus 6 feet. So feet squared for that one. Usually they don't tell us, and we put units squared. And then for number 12, this is a volume problem. A rectangular prism. Remember, your formulas are on the back of your checklist, but the volume of a rectangular prism is found by taking just the three dimensions and multiplying them together, length times width times height. Either of these sides can be the length or the width. Like some of you might say that's the length and that's the width, and others of you might look at it differently and do it the other way around. I definitely think that a plus 1 is the height, because that's how tall the box is. But if the box was rotated a little bit, it could be the length or the width. So it really doesn't matter what order you write these in. I'm just going to kind of do it how I have them labeled. So I'm going to say it's 2a minus 2 times a plus 5, and then times a plus 1. Now, don't try doing all of this multiplying at once. We are going to, at the beginning here, basically ignore the a plus 1. It's just kind of going to be there hanging out. We will multiply with it second, okay? So the first thing we're going to do is just take these first two binomials, use the FOIL method, and get that answer. And then we'll take it times the a plus 1. Alright, so 2a times a is 2a squared. 2a times 5 is 10a. Insides gives me negative 2 times a, which would be minus 2a. Outsides gives me negative 2 times 5, negative 10. I'm just going to copy the a plus 1 just so I don't forget about it. I'm intentionally forgetting about it for a little bit, but I don't want to seriously forget about it. Simplify what we just got right here with the a's. You can combine those together. So 2a squared plus 8a minus 10. And then that is a trinomial that we are then taking times the binomial a plus 1. So now we are ready to take that a plus 1 and actually use it a little bit. This is going to look a little bit backwards from what the top of this page of the notes looks like. But I'm going to take the a plus 1 and we're going to just double distribute with it. So I'm going to start with the a and take it times each item inside of that trinomial. So that will give me, let's see, a times 2a squared. So that's 2a to the third. And then a times 8a, that would be a plus 8a squared. And then a times a minus 10 would be negative 10a. I hope I said that right. 2a to the third plus 8a squared minus 10a. Now we need to distribute with the 1 that's still there. So take this 1 times each item inside of those parentheses. So that's not really hard to do because it's times 1. So 1 times 2a squared is 2a squared. 1 times 8a is 8a, so plus 8a. 1 times a minus 10 is a minus 10. Finally, combine like terms. I'm going to have to write my final answer off to the right here. Any a to the thirds? Sure, we have just the first one, 2a to the third. Then we're done with that. What about a squared? We have 8a squared plus 2a squared. So those are both positive, so that would be 10a squared. Then we have a negative 10a plus 8a. That's negative 2a. And finally, we just have that minus 10. Okay. So there is the answer. I knew I would forget my label. This time they didn't tell us a certain measure, so we would just put units. But it's volume, so you put units to the third, units cubed. There, that is the final answer for the volume of that rectangular prism. All right, this lesson is a really important lesson, so if you have any questions as you're doing the practice quiz and the assignments, please make sure you ask. Multiplying binomials and trinomials is an important thing that you need to know how to do.